Next up, I have this little project for my aerospace friends, and it's a quick project to make some locating blocks, and it's 4 blocks where this dimension changes each time. There's a table up here that shows the changes in dimensions. They're all very close to each other, and so what I might do is make a larger piece of material the largest width, and then remove some material for all the others. Most of the dimensions are pretty easy and pretty light. The 2 decimal point specified dimensions are plus or minus 10 thousandths, so those are no big deal. I think I might have to relieve the corner because he wants it sharp. So we're gonna do that so that he can fit a piece right up to the edge there, because every tool is gonna have a little bit of a radius, and that might be a problem. So I'm just gonna try and find an appropriate piece of stock. Found a piece of cast aluminum tooling plate. Mike 6 is what the trade name is for it from this particular manufacturer. And the advantage of it is that its thickness is about accurate to about 1/1000th over the whole size, which is pretty nice. You can use these for handy shims and things like that, so always keep some around. Tooling plate is kind of interesting because it comes with a plastic coating to protect the finish on it, and kind of looks like it was Blanchard ground. I don't know if that's the case, but it really does look like it, these striations. I've had these way covers as long as I've had the mill, and they worked sort of. They've never been great. These don't really lie down deeply enough in the slots, even before I got these pieces that fit in there to keep chips out. They do prevent the surface of the table from getting scratched, so it looks very, very good. But they warp when they get hot with hot chips on them. Look at that. They've warped really badly. So these were the most common ones available. And then I saw that MSC sold an interstate version, which I purchased. So these guys fall off all the time. They don't stick in there well. So the interstate version, I'm very disappointed with the quality. It's really thin vacuum formed plastic, it looks like. Have little ridges along the outside edge. So I think they're designed to sit somewhere down here, which is not long enough. This is designed for a 9x49 Bridgeport, supposedly. Gotta say, not very pleased with the quality of this one either. I generally like to keep my ways covered and protected. So I think I'll be looking for another solution. This is not a great one if you want to keep the majority of your ways protected at all times. I will keep chips out of the pockets at the end, but I don't know. I don't think it's particularly great, but I will let you know more as I use them. I think what I will end up doing is machining some aluminum that fits over here to protect the ways, like, and put some, attach some slot pieces on it that go deep in the slots. I think that might be a better solution long term. Tom Lipton's solution was a piece of, 2 pieces of plywood. That may be a good solution too. Just going to take a quick pass, 25 thousandths. Going to come back and do a quick pass on the saw cut side. You can see the saw marks on it. Taking off 165 thousandths at a go. Actually getting a great surface finish out of this, even though it's 165 thousandths. Pass. Finishing pass 6 thousandths to get to my largest dimension of the 4. And interestingly enough, I think the guy who drew this drawing was trying to keep me on my toes, because you'll notice that the sizes aren't in order. It goes down, 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 up. And if I were to remove material in order of these here, I would remove too much material to be able to make the last part. So, got to remember that. Okay, now I've got the stuff horizontally, and I need to remove everything but the 1/4 inch on the edge here, down 1/4 of an inch. Here's the interesting bit with this stuff. It's so flat right out the gate that tapping it down very lightly with the mallet made both parallels stick perfectly. And That's something that you don't get unless your part's really flat, and that's quite impressive, to be honest with me, because a lot of times you only get one to stick and the other one's a little bit loose, and that's if there's some sort of canting going on. So that's pretty good. I decided to try 75 thousandths. We'll see. Hopefully that won't be too aggressive. Don't have a ton of experience, so yeah, before I continue on doing the slit, I need to make sure my sides are square. All right, so I just loosened up my milling head, brought it this direction about an inch. Now I've got enough travel to make it. This is an 8-inch part, and I think I've got like 10 or 12 inches of travel, so I should be able to cover the whole thing. I just need to line up the blade right in the groove, and we'll cut. My setup is a couple of angle blocks, 45s. I have 2 sets of angle blocks because if you want one on each side, you need 2 sets. Fortunately, the Chinese ones are fairly inexpensive, and if you don't need super precision, they're probably more than adequate. I could have used my Tom Lipton adjustable 45s that strap on each side of the vise, but I didn't think that was necessary in this case. I had to be very careful not to over clamp this because it could very easily bow in the middle, and then my depth wouldn't be consistent. So I had to take all those things into consideration, and now we're just going to try and cut. Oh, and with the I got my blade upside down. Oh, too funny. I got to flip this around, otherwise I have to run my mill in reverse, which would also be okay. And we are done. All right, so first dimension 2.960, it's actually 2.961, and cut this end off. So now I've got some rough ends. So I've got to pop this guy back in here and just clean it off. I want to make it 1.5 total, and then I got to clean this side off here and then remove some more material so that it's the new thickness, and repeat and rinse and repeat. Here's my measurement, 2.710. Right on the money using the depth point on my calipers. Now I know that's not a super precision method, but I got plus or minus 5 thousandths for this part, so we're going to call this one good. Interesting holding problem. The step makes it hard to hold and support, so I'm taking a 1/2 inch parallel, sticking it in so it sticks out proud, and that way we can clamp on this guy and we can remove it down to final size. Now I need something sticking out one of the sides here, so I have room to measure. There's our final blocks. They turned out pretty well, all within spec. I would have liked to get them right on the money, but using a depth mic is pretty challenging to get an accurate measurement. It has so much leverage with the threads that it's very easy to lift the flat plates off the part and you don't even notice it. Just a little bit of force, and that the mechanical advantage of a screw really moves it off. But I had to make the measurements multiple times, and it was very challenging. I think if you put this on a surface plate and used a gauge with gauge blocks to set a height and compare it, that would be the way to get an extreme precision out of it. This was challenging. In the future, if I need more precision than this, I think I know the route to go.